Everybody, on to 4.1b now, called the second derivative test. This is supposed to be a shortcut to the first derivative test that you did in section 3.4. It was on test 3. The idea is this: we take the knowledge we learned in 4.1a about concavity and we use it to justify whether we have a local max or a local min. Okay. So for example, the idea is this: if something's concave up, a shape like that's concave up, then you're going to have a low point here, a local min. Okay, so this again is concave up. Something's concave down, well, that's upside down. So concave down, oops. If that's the case, then you got a high point, which is a local max. So based on whether we have concave up or down, which we learned in 4.1a, we can tell if we have a min or max just based on that. Okay, so the official rule is this. For the second derivative test, we take a critical value, C, plug it into the second derivative. If it's positive, that gives us concave up. Again, that's what we have on the top here. We've got to have a local min, specifically at that x value C, critical value. And just the opposite down here. If we plug the critical value into the second derivative and it's negative, that's concave down, got to have a local max. At C, at the critical value. Now theoretically, it is possible to plug a critical value in and get exactly equal to 0, but you're not going to have that situation in any of the questions that we give you. So these are really the only two situations we're going to worry about here. Okay, so this is called the second derivative test. Alright, so what do we need to do this? We need critical values, C. Those come from the first derivative. Okay, so we've got to get our first derivative. Okay, so let's go ahead and do that here. So derivative of negative 9x squared is negative 18x. Derivative of negative 126x is negative 126. Derivative of negative 405 is 0. To get a critical value, as we did in 3.4 and 3.5, we set the derivative equal to 0 and solve for x. Okay. So negative 126 divided by 18 is going to be negative 7. Okay. So remember in 3.4 when we first learned about local max and min, we also had to get the y values. So we might as well go ahead and calculate y since we have x now. So remember, y is going to come from the original function. So take that negative 7, plug it in here, and you can get your y value. So negative 9 times negative 7 squared minus 126 times negative 7 minus 405. Y is going to be, calculating that, 36. Okay. Alright, so your critical point is negative 7, comma 36. Alright, so you've got to determine, is that a maxima or a minima? Okay, so now we'll go over here and we'll look at what the rest of the second derivative test said. We take that critical value, that negative 7 we found, we plug it into the second derivative and determine if we get a positive or negative when we plug in that value. So we need our second derivative. Okay. So here's our first derivative. Derivative of that would be negative 18. Okay. Plug in your critical value c, which in our case is negative 7. If we plug in negative 7 for x, we still get negative 18, which is negative. Okay. So we've got the bottom situation down here. It's negative, less than 0, so we've got a local max at c. Alright, and there we go. We can answer our question from that. So we know we have a local maximum, negative 7, 36. We don't have any other critical values, so there's just a button for you to click on Hawks that says no local min. Alright, if you remember the way we did these problems in 3-4b, after we got our critical value, we had to make a sign chart, like a number line with our x values on it, and plug test values into the derivative. And this is just supposed to be a little bit quicker. You don't have to make that sign chart, and theoretically you won't have as many numbers to plug in using the second derivative test as compared to the first derivative test. However, if you get stuck for some reason and you want to go back and use the first derivative test, you can. You'll get the same answer we got here. This is just, again, supposed to be a shorter way to do it. Alright. Let's look at another one. So we've got a little bit bigger exponent here. So theoretically we can get more critical values, but the process is going to be the same. Okay, so let's do it. First derivative, negative 12x squared minus 60x minus 48. Set that equals 0. Solve for x. Notice I can factor a negative 12 out of here. It's going to give me x squared plus 5x plus 4, which is going to factor into x. It's got to be what? 4 times 1, so plus 4 and plus 1. Alright. When you break that apart, just as a reminder, for 0 equals negative 12, there's no x value to solve for. So we don't get any critical values from that. Okay. Solving the other ones, you'll get negative 4 for x and negative 1 for x. Okay, so both of those are theoretically critical values. Again, you can go back up here to the original function to get your y values. Let's go ahead and calculate those. If we plug in negative 4 into the original up there, let me get my calculator here. Negative 4 times negative 4 cubed minus 30 times negative 4 squared minus 48 times negative 4 minus 24, I get negative 56. Okay, so that's negative 4 comma negative 56 is a critical point. If we plug in negative 1, negative 4 times negative 1 cubed minus 30 times negative 1 squared minus 48 times negative 1 minus 24, I get negative 2. So negative 1 comma negative 2 is a critical point. Okay, so compared to the last problem, we end up with 2 critical points instead of just 1. So we've got to test both of them. Alright, so we need our second derivative, f double prime of x. Okay, so here's our first derivative. Take the derivative of it. Derivative of negative 12x squared is negative 24x. Derivative of negative 60x is negative 60. Derivative of negative 48 is 0. And let's test both of these critical values we found. If I plug in negative 4, negative 24 times negative 4 is going to be 96 minus 60. I'm going to get 36 there. That's positive. So again, flip back over here for just a second. If it's positive, you've got this situation. You have a local minimum at C. Okay, so local min at negative 4. Alright, and then we got to test the other one as well. So if we plug negative 1 into our second derivative, negative 24 times negative 1 is positive 24, minus 60, that's going to be negative 36. That one's negative, and that's going to be the opposite situation. Again, flipping back over here for just a second. If it's negative, we saw we had a local max. So local max at negative 1. Alright, so there we go. We can answer our question now. For the local max, it was at negative 1. So again, we found that point right here to be negative 1 comma negative 2. For a local min, that's at negative 4. When we plugged in to get that point, we got negative 4 comma negative 56. Alright, so again, it's the same thing we did in the previous problem, it's just we had a second critical value to look at. So you've got to test both of them. Alright, moving on. Alright, now they've increased that exponent again. We're at x to the 4th now. So again, theoretically, that means you can have more critical values to test. But the process doesn't change. Okay. So let's go through and do the same thing again. First derivative, 4x cubed minus 16x. Derivative of negative 12 is 0. We're going to set this equal to 0 to solve for x, our critical values. And a second factor of 4x out of this. It's going to leave me x squared minus 4. And x squared minus 4 is the difference of squares. So that's x plus 2 times x minus 2. Okay. So we get 0 equal 4x, 0 equal x plus 2, and 0 equal x minus 2. We do have an x over here on this first one this time. So if I divide each side by 4, x is going to be 0. For the middle one here, x is going to be negative 2. And for the one on the right here, x is going to be 2. Okay, so 3 different critical values this time. And once again, you got to have your y values for each one of them. So if we want to get our y values, go plug them into the original function up there. Alright, so if I want the y value when x is 0, 0 to the 4th minus 8 times 0 squared minus 12 is going to be negative 12. So 0 comma negative 12 is a critical point. For negative 2 there, negative 2 to the 4th minus 8 times negative 2 squared minus 12. Plugging it into my calculator here, I get negative 28. So negative 2 comma negative 28 is a critical point. And then if we plug in positive 2, I'm also going to get negative 28. So 2 comma negative 28 is a critical point as well. So, okay, we had 3 critical values, so we've got 3 points to look at. test all three of them in the second derivative this time. All right, so our second derivative of 4x cubed is 12x squared. Derivative of negative 16x would be negative 16. We want to go through and plug in all three of those critical values. Alright, so if we plug in 0, 12 times 0 squared is 0, minus 16 is negative 16. That's negative. So again, look back. If the second derivative is negative, it means concave down. So you have a local max at that x value. Alright, if we plug in negative 2, negative 2 squared is 4, 12 times 4 is 48, minus 16, that's going to be 32. That one's positive, so the opposite situation. If the second derivative is positive, you have concave up, so you must have a low point, a local min for that one. And then if we plug in positive 2, we're also going to get 32 there. So it's just like what happened with negative 2. Alright, so we've got one local max and it's at 0. So that point was 0 comma negative 12. So 0 comma negative 12 for the local max. And we have two local mins at at negative 2 and at positive 2. Okay, so that's negative 2 comma 28 and positive 2 comma negative 28. Alright, so whenever you need to list multiple points on Hawks, just make sure you put a comma in between them. Doesn't matter which order you put them in, just make sure you put a comma in between them. So negative 2 comma negative 28 comma 2 comma negative 28. And there it is. Alright, now that's as big as we're going to go in this class is basically to have three of them, three critical values, so three extrema. You know, if the function gets a little bigger, you know, you could have even more than that. But we get the idea with just going to three different critical points. So we're not going to go any bigger than that in this class. Alright, these first three questions, the functions have all been in polynomial form. The last two questions, the function given is not written as a polynomial. So look at this one. It's x squared plus 4 all squared. Even though that's not technically written like a polynomial, we can multiply it out and write it as a polynomial. So what does this squared mean? It means you have x squared plus 4 times x squared plus 4. If you multiply that out, x squared times x squared is x to the 4th. X squared times 4 is 4x squared. 4 times x squared is another 4x squared, so you have 8 of those. 4 times 4 is 16. So even though it's not written as a polynomial to begin with, all you've got to do is multiply it out, or you might have called it FOIL in high school. Just multiply it out, and now it looks basically like number 3 looked. This is x to the 4th type of function. That's what we had here in number 3. So it should be kind of similar. All right. They actually are asking for the second derivative in step 1 here. Some of the questions ask for that, some of them don't. When we get to the second derivative, we can write that in, but just because they have this broken into 2 steps doesn't change anything about the way we work it. Alright, so let's work it the same way. First derivative of x to the 4th is 4x cubed. Derivative of 8x squared is 16x. Derivative of 16 is 0, so that's gone. Set this equals 0. Solve for x. I can factor a 4x out of here. It'll leave me x squared plus 4. Okay, here's a little bit of difference between this and the last problem. In the last problem, look in parentheses right here, we had x squared minus 4, which factored into x plus 2 times x minus 2. That's not what we have on this one. We have x squared plus 4. That doesn't factor. That's okay. Go ahead and set each factor equal to 0 and solve for x. So from 0 equal 4x, we're going to get x equals 0. For this one, let's say we'd subtract 4 over. We'd have to do the square root of both sides. Remember, in algebra, when you do the square root of both sides, you have to technically consider plus or minus. Okay. There's still an issue here, though. On the left side, I'm trying to do the square root of a negative number. We can't do that. In business calculus and really in any kind of business class, we only deal with real numbers. You may remember something called imaginary numbers or complex numbers in high school. That does have applications in places, but not in business. Okay, so for us, we're not going to get anything on this. You can't take the square root of a negative. Now, if we were dealing with electronics or physics, something like that, it'd be different. We'd have to deal with imaginary numbers, but we don't have to worry about that in business. So we actually only have the one critical value, 0. Okay. Let's go ahead and get our y value for it. Okay, so 0 to the 4th plus 8 times 0 squared plus 16. It's going to be 16. So we've got a critical point of 0, 16. All right, test that single point. We need the second derivative to do that. So the derivative of 4x cubed plus 16x would be 12x squared plus 16. And we can go ahead and answer step 1. 12x squared plus 16. And then we plug our critical value into that second derivative to determine local min or max. So 12 times 0 squared is 0 plus 16 is 16, which is positive. So again, if it's positive, we're going to get a local min. So we just have the one point. It's a local min, 0, 16. There's no other critical values, so no other critical points. So we don't have any local maxes. All right. One more problem, and it's going to look similar to that. Just want to go through that one more time with you. So this time we have x squared minus 9 all squared. Okay, so again, kind of looks like question 4. So likewise, we can multiply it out. This would be x squared minus 9 times x squared minus 9. Multiplying that out, that's x to the 4th minus 18x squared plus 81. Okay, let's go ahead and get our derivative. F prime of x, 4x cubed minus 36x. Root of 81 is 0, so that's gone. Set this equals 0 and solve for x. I can pull a 4x out again. It's going to leave me x squared minus 9. Okay, so x squared minus 9, that's the difference of squares. That will factor. So I've got 4x times x plus 3 times x minus 3. Okay, so go ahead and solve in this. I'm not going to write down the things separately this time, but if 4x equals 0, then x equals 0. If x plus 3 equals 0, then x equals negative 3. And if x minus 3 equals 0, then x equals positive 3. So 3 critical values. Plug them into the original function up there to get your critical points. So we're going to need to plug in, go ahead and plug them in here. If I plug in 0 in the original function there, I'm going to get 81. So 0 comma 81 is a critical point. If I plug in negative 3, let me get my calculator here. Negative 3 to the 4th minus 18 times negative 3 squared plus 81. I get 0. So negative 3 comma 0 is a critical point. And then go ahead and plug in positive 3. And that's going to be the same thing. Okay. So 3 comma 0. Alright, so there we go. 3 different critical points. So 3 different points to identify as maxes or mins. Let's get our second derivative now. So again, here's our first derivative. Take the derivative of it. That's going to be 12x squared minus 36. Go ahead and put that in here for step 1. 12x squared minus 36. And then our local maxes and mins. So again, we've got to test all 3 of these in that second derivative. Alright. So if we plug in 0, we're going to get negative 36. That's negative. So you know you have a local max. Local max at 0. Okay, if we plug in negative 3, okay, so negative 3 squared times 12 minus 36. Okay, I get 72. That's positive. So you have a local min there. And then if you plug in positive 3, you're also going to get 72. Okay, so that one's also a local min. Alright, so we've got the one local max at 0. That point was 0 comma 81. And then we've got 2 local mins at negative 3 and 3. So those points were negative 3, 0 and 3, 0. So remember, just put a comma in between the points when you list them on hogs. All right. Take a look at the homework.